Each district of this city is enchanted with a different spell, or at least that's what the Arcane Bros sold to their investors. I'm going to make the argument for why each of these districts failed, and it actually relates to one of the most important concepts in astronomy. First, let's talk about how a spell city works. This, for example, is the Hold Monster spell from my spell writing compendium. Each of these really big long boulevards defines the spell. Now, in my actual theory of magic, this wouldn't cast a spell, but I think it's really fun to think, what does it mean for a city to be a spell rune? Each of these runes has 13 points. So the idea for this city was one city that has a whole load of districts made of a 13-sided shape that will then have a spell in each district. In the lore, I then have a load of Arcane Bros taking in a load of investment for people trying to buy plots of land in, the different districts. One thing you'll notice about this city compared to this one is how hard it is to see where the spell lines actually are in the districts. So I'm going to talk about something called signal to noise ratio. Let's imagine you're a wizard and you've got this lovely arcane detection device. And let's say you calibrate these devices by pointing them at the top of mountains, because as we all know, the top of mountains are magical. You know for a fact that as you move your telescope across the peak of the mountain, so here is where the peak is, the amount of magic you detect should go up and then back down as you go across the peak. But instead of seeing that, you see this with a whole load of bumps. This is not a very good demonstration of noise. But never mind, you see a load of bumps. So you've kind of got the model shape, but you seem to have these up and down moments and maybe a few artifacts like that. How confidently can you tell that this is in fact from a signal and not some random effect from your device? Well, in astronomy, we always use this thing called the signal to noise ratio. And this comes up everywhere. It is very simply the strength of the signal divided by the strength of the noise. So in this example from Wikipedia, because Wikipedia is pretty good for some physics stuff, here we have a really strong signal compared to the noise, but gradually as we add in more and more noise, we get a less and less clear image. That is to say, it gets harder and harder to discern what is signal and what is noise. This is really important in astronomy. If we observe for a long time, we will have a higher SNR and be more sure that what we're seeing is a signal rather than a random effect. Another really cool one is in gravitational wave observatory, so things like LIGO, where they're looking for tiny changes in distance because of the stretching and squeezing of space-time. LIGO's really cool, you should look it up. But as you can see, there's quite a lot of noise in this, and so they need to work really hard to reduce that noise and to be sure that what they're seeing is in fact a signal. And so this is a high SNR magic city, while this is a low SNR magic city, so I don't think the enchantments would work. I don't know, maybe they still will. Let me know what you think in the comments. Anyway, have a lovely day. Okay, bye.